Welcome to the course. I'm Daniel and I'm so excited to teach you how to stream big data sets with Spark Streaming and various other technologies that we will integrate in this course. This video will serve as a short introduction to how the course is structured and how to approach it. So, first, check your welcome email. It contains important information about the course, as well as your payment details in case you need to reimburse this with your employer if you need or want it. In addition, this welcome email will contain a very important button, this dark purple one, to join our conversation in our private Slack room. On the Slack room, we're going to talk about Scala, Akka, Apache Spark, talks, conferences, employment opportunities, and I'm going to share the latest updates with Rock the JVM before everyone else, and private discounts. If you haven't done so already, go ahead and click this button and join our Slack community. Even if you don't have a Slack account, it should only take a minute. Alright, now after you've done that, I'm going to ask you to install IntelliJ IDEA, which is going to be our development environment for this course. Now, because we're doing Spark Streaming, this already assumes that you already know how to write Scala and you also have some Spark skills, which makes me assume that you have IntelliJ IDEA already installed. But just in case the zombie apocalypse erased IntelliJ IDEA or some development environment from your computer, go ahead and go to jetbrains.com/idea and click on this black download button. And after you've done that, go ahead and download the community edition for JVM. This includes Java and Scala, and it will support Scala in the form of a plugin. So go ahead and download that. It will extract a wizard on your computer, and if you click on that wizard, the wizard should be really straightforward. And at the first launch, IntelliJ IDEA will invite you to install the Scala plugin, which is a featured plugin for IntelliJ, and obviously I recommend you do that for the course. So if you haven't downloaded IntelliJ IDEA already, I will recommend that you pause the video and install it now. Awesome. After that, I will ask you to go to docker.com because we will integrate various technologies with Spark Streaming and I don't want us to waste any time setting them up. And so I've already set up some Docker containers that already have those installed, and I will ask you to go to docker.com and go to products and click on this Docker desktop. So I will invite you to go ahead and install Docker Desktop for your platform, Mac, Windows, or Linux, whatever you have, and click on this download for your platform, and again, the setup should be really straightforward. So if you don't have Docker on your computer, I will again invite you to pause the video and install it now. Now, a word of warning for Windows users. This Docker will not work on Windows Home Edition because it doesn't have a feature known as Hyper-V that allows virtualization on your computer. So if you have a Windows computer, it's recommended that you have a professional version of Windows. Alternatively, I will recommend to install a Linux operating system on your computer as well. Good, so if you don't have Docker on your computer, I will recommend you pause the video and install it now. And after you've done that, go to our GitHub homepage. So go to github.com/rockthejvm and click on this Spark Streaming link. So the final URL is going to be github.com/rockthejvm/Spark Streaming, and go ahead and click this bright green button and clone or download this project. If you know how to use Git, we also store intermediate states that I have created throughout recording the entire course. So you have here intermediate tags that you can check out before me recording any lecture. So if you want, for example, to check out the state that the repository was in before I wrote the Kafka dstreams lecture, then you can check out this tag and then you can follow along with my code with everything below that or everything before that already implemented for you. Alternatively, if you don't know how to use Git or if you've never used Git before, go to this Releases tab on the Git page, and you have here the state that the repository was in before I recorded every single lecture, which you can download as zip archives. So go ahead and click on these tiny little zip links so you can download the state that the code was in before those lectures. That is in the case that you've never used Git before. So after you've downloaded the project that you're going to use in this course, if you've downloaded that as an archive, go ahead and extract that and open the resulting folder in IntelliJ, which should be really straightforward. And after you've done that, the project should look something like this, in which we have a bunch of folders and a bunch of files. And I will explain what those are in just a second. So let's go through the files step by step. Spark Streaming is the name of the project, and we have a bunch of folders. The .idea is specific to IntelliJ. We have a folder called Flume, which contains a configuration file for the Flume Docker container that we're going to integrate in this course as an optional lecture, because the Flume integration has been deprecated since Spark 2.3, but some people are still using that, so we are going to do that as an optional lecture in this course as well. So we have this Flume configuration folder. Then we have the project folder, which has been generated by IntelliJ. We have no business here. This contains the compiled classes and so on and so forth. We have a SQL folder, which contains a SQL database that is for the Postgres container that we are going to spin up in this course. Now the db.sql is a little bit big, so we have a 13 megabyte file with quite a bit of data in this Postgres database for us to play with. And so we will use this db.sql as standalone data in the Postgres Docker container. Now, we have the source folder, which is by far the most important part of our project. And in source main Scala, we will write our code. Now, this folder is where all the fun is going to be, so I'm going to leave that last. So under source main, we will have some additional files. We have an HTML that we will use at the very end of the course. We have a small HTML file with a very primitive UI that I wrote with JavaScript. And I will explain what this does very late in the last project of the course. Then we have source main resources, which will contain a bunch of files. We will have a configuration folder for Akka when we will integrate Akka remoting in our system. So we will integrate Spark with Akka and Akka streams, which will be pretty exciting. And with those techniques, you will learn to integrate basically anything, because Spark and Akka are not necessarily naturally compatible. And then under source main resources data, we have a bunch of data frames that we are going to be reading in a streaming fashion. So I'm not going to detail what all these are. We're going to explore them in due time. Now, at the very end of the resources folder, we have a file called Twitter4j properties, in which we will configure some Twitter authentication details for a Twitter application that we are going to create. So we will have a standalone project where we will aggregate tweets in real time from live Twitter, and we will do sentiment analysis on those tweets. And for that to work, we will need to provide some authentication details here in this configuration file. I will detail that when we explore the project. So that's what source main HTML and source main resources does. I will detail Scala a little bit later. Let's explore the other files. So we have gitignore just for Git state management. Then we have build.sbt, which contains all the library definitions that we're going to use in this course. And for this particular course, we have a bunch of libraries. So first we have org Apache Spark, Spark Streaming, and some integrations with Spark Streaming. So we have Spark SQL Kafka, Spark Streaming Kafka, Spark Streaming Kinesis that we unfortunately won't be able to use because Kinesis is not really compatible with us. We have Flume, which we will uncomment only when we explore the Flume integration as an optional lecture, because Flume has been deprecated since Spark 2.3 and works on Spark 2.4. I've tested that, and we will detail that in due time. And then we have some libraries for Akka so that we can integrate Akka with Spark. Then we have a library containing a Cassandra connector for Spark Streaming, a library for Postgres, 2 libraries for Twitter so that we can call the Twitter REST APIs through some Java wrappers. And then we have some additional libraries here, 2 for logging, 2 for sentiment analysis from Stanford, and a plain library for Kafka, because we will manually send some data through Kafka, and we will detail that when we operate with our projects. Now, as for versions, we have a bunch of versions here. I've set them up for you so that you don't waste your time setting these up and ensuring compatibility. The most important version is Spark version, which at the moment of this recording is 3.0. When you open this project in IntelliJ, the development environment will offer to download all of these libraries for you, which of course you should. and it will appear in the form of a small pop-up on the bottom right-hand side, offering to import changes. So if the IntelliJ IDEA development environment doesn't download all the libraries for you, just click this import changes button and the libraries will be automatically downloaded and ready. And once the downloading process has finished, I'm going to go ahead and click on Source Main Scala Playground and click on this Playground application and then right click and just run it. So if you run Playground, then that means the libraries were downloaded correctly and you should be good to go. You should be good to write your code. So if you see any output here in the console, then that means the libraries were set correctly and they also run in the meantime. Okay, so I'm going to stop the application. So this is what Playground will do. It's a small test application with Spark and Spark streaming. Feel free to play around with it and fiddle with the code as you see fit. Now, under the comments package, I promised I would explore that as well. We have some data definitions that we will use throughout the entire course, and I set them up for you so that you don't need to waste your time defining the data for this course. So these are some of the Scala files that we are going to use in this course. And of course, as we need them, I will also detail what they mean in due time. So let me collapse the Scala folder because we're done with that. And I left at build.sbt. Let's detail what the other files mean. We have a file called Docker Compose YML, which contains the definitions for all the Docker containers that we are going to use in this course. We have a Docker container for Postgres, we have one for Cassandra, one for Zookeeper and Kafka, so that Kafka can work correctly, and then we have a Docker container for Flume as well. When you hit Docker Compose up, all of these Docker containers will spin up, and we will see them in the console shortly. I will show you how. So this Docker Compose YML will contain the definitions for the Dockers that we are going to use in this course. Now, for connecting to the Docker containers, we have two additional files. We have an additional psql.shell, which is a shell file that will run this command, docker exec-it whatever, that will allow us to connect to the Postgres container so that we can inspect the data that we write from Spark. If you're on Windows and you cannot execute shell scripts, just run this command. Just copy and paste this into your terminal. So when you open a window command prompt, you simply need to pass this command. Also, with the CQL, which is the script that we will use to connect to Cassandra, again, you will need to simply paste this command. And this command will simply connect to Cassandra and will start a command prompt there. Cool, so we have Docker Compose, psql shell, and CQL shell. We also have another shell script, docker-clean.shell, which runs this command, which will purge all the Docker containers that you have set up on your computer so that all the state is clean on your Docker containers. So when you want to spin them up again, you should do Docker Compose up. I'll show you how. And if for some reason one of your Docker containers is in a very weird state, just do docker rm-f, whatever this command says, or simply execute docker-clean shell, and all of your Dockers will be wiped, and you will need to start them again. Whew, lots of files. But let's go to the terminal and start up our Docker containers. So open a terminal window on your computer and navigate to the folder that you used for this course. So right now I'm in my Spark streaming course folder, and I will run the following command. I will say docker-compose up. So Docker Compose up will start all the Docker containers specified by that Docker Compose YML file that I showed you earlier. So just click on this one, and at the first launch, Docker will take a bit of time to download the appropriate images and to spin them up. And after you've done that, after you've downloaded the images, which might take from 2 minutes to even half an hour, depending on your internet connection, the Docker containers should spin up really quickly in under 10 seconds. So the first launch will be a little bit long, but the subsequent launches will be really quick. So just under 10 seconds. Now, a word of warning. If you're trying to download these Docker containers and or the libraries that I showed you earlier in build.sbt and your Playground application doesn't work, because you're working on a work computer for this course, then it might be the case that your company's firewall is preventing either IntelliJ from downloading the libraries or the Docker agent from downloading the appropriate images and spinning them up. So that is a common problem that I've seen with the students of the Spark Essentials course. So make sure you're aware of that. Now, the final thing that you will need to install in order to send data through a socket that we will later use for reading data into Spark Streaming is to install a program called Netcat, which for Linux and Mac users should already be installed. And on Linux and Mac, Netcat is accessible by the command nc. So if you do nc-lk12345, then this will open a small server in which you input some data as strings, and this data will be sent through a socket that will then try to listen on 1, 2, 3, 4, 5. And we will use Spark Streaming to listen to a socket at this particular port, and in a terminal we will open one of these Netcat programs and we will input some data so that Spark can read them. Okay, so make sure you have this NC installed on your computer. If you have a Linux or a Mac operating system, make sure you have nc installed by typing which nc, and you should have something here. This means that nc is installed on your computer. If you don't, then do apt-get install nc if you're on a Ubuntu or some other Linux distributions, or use your favorite package manager. If I'm on a Mac, I would use brew install nc. So that was for Linux and Mac. Now, if you're running this on Windows, then you will need to install a Netcat program for Windows. So open another browser tab and try to search for Netcat Windows, and go here to this website nmap.org. So click on here. This looks like a 90s website, and click on this small download link, which will get you to a downloads page for all the operating systems. So for Microsoft, you would do nmap-780 setup exe for a web installer, or if you want to download that as a zip file which already has the command compiled, then you would download this nmap780-win32.zip, and you would unzip that. After you unzip it, you would get this ncat-exe. This is the executable that you will use in the course. So if you want to start up Netcat, you would start a terminal, navigate to this folder and type in ncat-exe, and then you would pass in the same arguments that I pass in my terminal on Mac. All right, so if I do nc-lk12345, assuming I can type 1, 2, 3, 4, 5, you do ncat.exe-lk12345. The Windows Netcat should receive the same command line arguments as my Netcat here on a Mac, or the Netcat command on Linux. If it doesn't work for any reason, do let me know immediately in our Slack room and I will jump in to help. Alright, so this video was pretty long, but this was the setup for the course, and you don't need to work on anything else but to focus on Spark Streaming. Now, before we start writing any code, join me in the next video where I'm going to give some pointers as to how to make the best out of this course.